All right, I probably should start the second recording here with mute off, right? So this is 9.2, and this is infinite limits. So it's really similar to what we've been doing with 9.1, and we still have some indeterminate form. But what if the graph goes straight up and has an asymptote? So it's getting close to a number and it's going all the way up to infinity. So, you know, what are we going to do then? So look at our note sheet here and notice here on this first one that it says the limit as you are approaching infinity. So we could be putting in infinity and seeing where we're headed. Where am I going? It's like end behavior. Where am I going, right? Or I could get out infinity, which is more towards the end here. So there's two kind of types of problems. Put in infinity, get out infinity. Now, if you put in infinity, you can still get out infinity, but these are both the things that are new to us. So look at this first one here. I have a number on top and x to some power at the bottom. If I put in infinity, the numbers will get bigger and bigger and bigger forever, right? So as the numbers get bigger in this exponent, that makes the fraction smaller. So it's going to 0. So if the denominator has a higher power and you're putting in infinity, you're going to 0. So I'm going to say that again. If the denominator has a higher power and you're putting in bigger and bigger infinity numbers, it's going to 0. And it could do the same whether it's negative infinity or positive infinity. Because the numbers are getting, I mean, it doesn't matter if they're negative if they're going to 0. So they're just going to 0 from this side or going to 0 from this side. They're still going to 0. Okay, and then this one down here. What if I don't have a fraction? I just have like x to some power and some value out front, and I'm putting in infinity. You can get out, it doesn't matter if I put a negative infinity or positive infinity. I could get out positive or negative. I have to put in some numbers and see what's going to happen. Like, all right, is it going to be negative or positive? Some of you will be able to look at it and know, oh, well, if k is negative, I'm putting in positive numbers. Positive times a negative is a negative. Or, a negative times a negative is a positive. You'll be able to think it through. Some of you'll get confused and you just need to put in a number like 10, then 100, and then 1,000. Where is it going, right? Because that's what putting in infinity is doing. Okay, so that's kind of what that top part of your note packet says. And then down here, it kind of looks, I don't know how to say that other than that kind of looks ugly. Basically, it's trying to say, like, if you have a polynomial that's counting down up here, so x squared x number, something like that. Same idea down here. Then the limit, as you're putting in infinity, you're looking at that highest degree. I couldn't think of the word. So I think this is just kind of a little ugly to look at it this way. Basically, if I have like x to the third over x squared, then the degree on the numerator is bigger than the denominator. And that's what it's telling you down here. It's like, okay, so if I have some kind of a polynomial, look at only the highest degree at the top and bottom. And if m is less than n, it's going to 0. So does the bottom have a higher exponent on the highest degree? If so, you're going to 0. It's the same with our asymptotes. Like, this is all similar, and looking at the end behaviors and things that we've done for a long time. Okay, if they're equal, so if I have x squared over x squared, x third, x over x to the third, again, on just the highest, the degree, then it's going to the fraction in front. So that's what it's trying to say here, the fraction in front. So it's the same as the horizontal asymptote. It's going to the fraction in front. Last but not least, if the top has a higher exponent than the bottom, then you're going to infinity. Now, whether it's negative or positive just depends on what numbers are there. So you could, again, put in a value to see if it's negative or positive infinity. But if you have an x to the third over an x and you're putting in bigger and bigger and bigger numbers, you're going to infinity. You might be going a little slower than the numbers you're putting in because it's dividing, but it is still going to infinity if the top has a higher exponent. Okay, let's actually do some problems. Now, remember, we have this idea of coming in from the left, coming in from the right, because we want to know where is it headed. We don't really care till we talk about continuous functions, where the value is. Okay, so let's look at this one. So this one's coming in, just a sec, I'm going to switch this. This one's coming in from the left. And so if we put in a -7 up here, I'm going to get a 0 in the bottom. But we're not really looking right at -7. We can do a little chart here, and I'm going to leave a little space for me to do my work. So x, y, or you can call that f of x, right? Either way. What if I just put in some values close to that -7? So if I think about -7 is right here, right in front of it's -6, right below it's -8. And I want to come in from the left side close to -7. So what number is really close to -7 from that left side would be a -7.1, right? Because it's on this side and they're getting bigger this way. And so let's put that value in and just see what we get. So we're going to put in a -7.1 on the top and then -7.1 on the bottom plus the 7. And I'm going to still have that -7.1 on the top. And the bottom is then going to be a -0.1. So when I divide those, I'm going to get a positive answer, and it's going to be getting, well, 7.1 divided by 0.7 is 71. Oh, hello, I could have just moved the decimal. Okay, so I didn't leave myself very much room. So if we want to get even closer, we can put in -7.01. Okay, so I didn't leave myself a ton of room here, but so -0.01 on the top is going to be -7.01, and then I'm going to just do my fraction this way. And then on the bottom, the 7.01 plus the 7 is now going to give us -0.01. So I'm going to divide those. 7.01 divided by, see how it's going to move the decimal one more, and I get 701. So I can see it's getting bigger and it's going towards infinity as I get closer and closer to -7. So this is the chart method. Now, in most regular calculus classes, they teach you a little bit different. They want you to think through the problem. They want you to think through, okay, I'm going to form a 0 down here. But what am I doing? So I'm going to write this out. This is how they think through it. So I have x on top, but they think through that this number is going to be negative and a little bit bigger, because it's like -7.1 or so, right? And then I'm adding 7. And they want you to think through, if you put in the numbers, that this up here would be negative, okay? Because I'm putting in a -7.1 and or -7.01 or whatever. So they want you to think through, this would be negative on top. This negative plus a positive, and it's bigger, would stay negative. Negative over negative is a positive, so it's going to positive infinity. I know that isn't the I don't know, like I can I'm a little bit different because I can look at this and go, okay, it's going to some kind of, it's got an asymptote. So it's either going to infinity. So, I'm a little bit different. But you could always go to a chart, always just plug in numbers and kind of see if I'm going to infinity or if I'm going to negative infinity. Okay, so let's look at the next one. Same idea, but now as we approach our -7, right? We're on this side. So we're approaching from the right side. So what number is that? It's going to be like, if I did a little chart again, then it's going to be -6.9 and maybe -6.99. Sorry, here we go. So then we're going to put that in, and we have -6.9 on top, and then on the bottom, -6.9 plus 7. So you can see this would be positive on the bottom now instead. So I'm going to have 6.9 divided by the 0.1 difference. So this would be 69, but it is positive. Oh, excuse me, it's negative. I solely said that wrong, but whatever. Negative over a positive will be a negative because this would be -6.9 and this would be positive 0.1. So it ends up being negative. Okay, so this side, if I put in the next value, I can see that it's getting negative and getting bigger. I could look at it just like I did before, like our x over our x plus 7, right? I could think this is smaller, right? So it's smaller but it's a negative, but it's smaller, and this one up here is negative. Just thinking through this, I can be like, okay, top's going to be negative. And it's definitely going to infinity because the bottom forms a 0 at the 7 or the -7. And this would be positive on the bottom. So I'm thinking negative over a positive. It has to be going to a negative infinity. So I can look at that and go, okay, it's forming a 0 in the denominator. Or I can make a chart. Both work really good. Okay, so where is the limit for the whole thing? Well, if the left and right do not match, then the limit at that value doesn't work because we got a positive infinity and a negative infinity. And I want to show this on Desmos, and look, I downloaded it today. Okay, so our function was x divided by, it was x plus 7, right? Yeah, x plus 7. So we can see, oh, I was like, that's totally not the right graph, plus 7. I'm like, where's the asymptote? Oh, and I can't get it to kind of go towards the bottom. Maybe if I use the pencil, perfect. Yeah, like that, I was like, that is totally not the graph. Okay, so let me type in that -7 here so you can just see equals y, and then you can see that, oops, equals x. There you go. So you can see that's the value we're looking at, right? We were putting in that -7, and we can see, I can't make it like highlight my pen. Yeah, to show you. It's all right. So you can see that it's going up to positive infinity as you approach from that left side, and it's going down to negative infinity. So we can look at that graph. So what I encourage you to do is do it by hand, see what you come up with, and then you can also do the little charts that we have here, right? The little charts we have here, and or think through if it's forming that 0 in the denominator. Okay, so let's look at this next one. So this next one, and I guess I should also say this is not a 0 over 0, right? It's not indeterminate. If I put in the number 7 that we're looking at, -7, excuse me, It's a number over 0. It's undefined. It is not 0 over 0. That's not the same thing. Okay. So if I look at this one, because I just thought of that because I thought, okay, if I'm putting in a 5 in this one, does it make 0 on the top? That's where my logic went. And it doesn't, because 5 times 4 is 20 plus 1 is not 0 over 0. But this 0 from the negative, the 0 on the bottom does form a 0. So it's probably going to an infinity. Okay, so this is our left side. So we're going to do it the same way. Let's do a little chart. And this time we're at +5. And so as we come in from the left here, coming in this way, right? And then this is our 6, whatever. We're coming in this way. I probably should have put my arrow up here. As you get closer to 5, it's like 4.9. Okay. So, because it's not negative, so it's a little bit easier to think through. So our x value is like 4.9, and we get out our y or our f of x, either way you want to call that. So put this value in again. I'm going to have 4 times the 4.9 plus the 1 over 4.9 minus 5 squared. And we're going to calculate that out. So I'm going to use my calculator. So 4 times 4.9 plus 1 is going to give me 20.6. The bottom 4.9 minus 5 is going to give me negative 0.1. And then I'm going to times that by itself, or oops. So it's going to be a positive. I should have got out a calculator because I'm using my phone. It's not that great. All right, there we go. So we're at this. So 20.6 divided by 0.01. I have a huge number and it's positive. What do we really want to know when we're plugging it in? Are the numbers getting bigger, and are they getting bigger in the negative direction, or are they getting bigger in the positive direction? So this totally looks like it's going to infinity. Okay, so I can put in 4.99 and double check that and see if how close it's getting as well. So 4 times 4.99 plus 1 is going to give me 20.96. On the bottom, it's going to give me, okay, so 4.99 minus 5 is a negative 0.01. So, and then I'm going to square that, and I get a 0.0001. And then I'm going to say, okay, 20.96 divided by 0.1231. And I can see it's getting really big quite fast. Oops, I did one too many zeros there. Beep. Okay, so I can see this is going to positive infinity. So the charts are the way to go if you logically can't think through the problem. So I look at this problem and I say, okay, it's going to form a 0 on the bottom, a number on the top, so it's probably at an asymptote, which means it's going to an infinity. It's where my logic goes, okay? So then I think, okay, if I put in a number lower, it's going to be negative here, okay? Negative squared is a positive. Positive over a positive is a positive. That's where I go. And I could just look at it and I could think it through. But either way. So let's do the same one, but let's approach from the positive side. So if we're approaching from the positive side, right, then we're coming in this way to the 5. So it's like 5.1. So in our chart, we can have our 5.1, then maybe 5.01 and so forth. So when I put this in, now I can't remember what the function is, excuse me. 4x. Okay, so it's like 4x plus 1. I couldn't remember exactly what it was. And then it's x plus, or yeah, plus 5. No, minus 5 squared. There we go. I'm going to write it down so I remember what it was. And then we'll get out our y over here. So the 5.1, 4 times 5.1 and then add 1 is going to give me 21.4 on the top. And then this time it's going to give me a positive, but it doesn't really matter because you're squaring it. So 5.1 minus 5 is 0.1, and 0.1 squared is 0.01. So I can still see this is going to be a positive. So 21.4 divided by 0.01 is 2,140. Is that the same? I don't remember. No, it's a little different just from the numbers. So we can see that this is going to positive infinity as well. Okay, so what about the whole thing now? So we looked at the right side, the left side, and they were the same this time. So because they were both the same, we can say this is going to positive infinity. Okay, we know 5 at that spot doesn't have a real value because it's an asymptote. It's undefined, but the left side and the right side must both be going to infinity. So let me look at that again real quick so I can type it into our graph. Let's look at this. It was 4x plus 1 divided. Oops. I got to do the dividing at the front. Okay. So 4x plus 1 over parenthesis x minus 5 squared. Okay. So, yep, there we go. At that value, we can see at that 5, we can see that it is getting closer and closer. And they're both going to infinity. All right, there's our graph. All right, ability. Okay. All right, so this next one, if I put the 5 in, so I look at it, put my little, oops. If I look at this one here, our next problem 3, and I'm putting a 5, get 0 here, do I get 0 here also? So 5 squared is 25 plus 5 times 3 is 15 minus 5. No, it's not 0. Okay. So I'm just double checking it's not a 0 over 0. It's not. It's going to be a number. So this is the same idea. You're putting in the values. And then this one, I was wondering where the ones are where we put in infinity. They're coming. Okay. This is the same one. I think we'll skip 3. So what we would do on 3 is the same idea. You're going to have a number on top by the bottom. So you can plug in those values and from the left on 5 and from the right on 5, and you can see if it's going to a positive or negative. Or let's look at it and say, okay, if I'm coming from the left side, then this number would be, it would be 4 point something. So it's going to be negative. And then if I put the 5 or the 4.19 or whatever it is on the top, I'm going to get a number that is positive. So it's going to be a positive over negative. So it's going to be a negative. So we can look through that. It's going to a negative infinity on this one. And the next one would be positive on the bottom, positive on the top. So it's going to a negative. So they're obviously like that first graph, like opposite. They're not both going up. Okay. So look at this one. What is different about this one is they are like saying put in a value, but ignoring this. I'm going to actually just cross them out for now. I just don't really care. So I want you to look at just this because that's how it's going to be formed on your homework, or not your homework, on your test. You have to know, okay, what is the limit of this as it approaches, or I put in infinity. So when I go to a test, it's going to be written like this: 5x minus 3 over 3x plus 2. And I'll show you why they're doing that. They set it up the way they did, which is fine. This is how that problem is going to be written. And if I'm putting in infinity here and here, that means I'm putting in bigger and bigger numbers. So I have to look, what is the power of the highest x's? They're both 1s. So if they're the same power here, then when I put in bigger and bigger numbers, it's going to the fraction in front. So the answer to this is 5/3. Now, why would they put this here? Is because they want to lead you to the 5/3. So they're saying, okay, what if you put in a 20? So I'm going to have to go 5 times 20 minus 3 over 3 times 20 plus 2. And what is that value? Okay, it should be a decimal somewhat similar to 5/3, but I don't know. So 20 times 5, 20 times 5 minus 3. It's 97. 3 times 20 plus 2 is 62. So 97 divided by 62 is 1.56. And 5 divided by 3 is 1.66 repeating. So we can look at this and go, oh, okay, it's getting closer at 20. What's going to happen is I put in 200. It's going to get even closer to this 1.666. So they're trying to lead you to the answer. So in your homework, it does the same thing, but you have to be able to look at it like this and answer it. So both ways. Okay, look at the next one. It's leading us to the answer by putting in a 10, then 100. But what is the limit as this one approaches infinity? Okay, well, the highest exponent on the top is a 1, and the highest at the bottom is a 2. So the bottom has a higher degree. Okay, putting in bigger and bigger numbers, what's going to happen? The bottom's going to get bigger faster, and the numbers are going to get smaller and smaller. So it's going to 0. Okay, so if we put in this 10, I wonder if I have a better calculator right here. I might. I mean, I hate phones for calculators. They're awful. So here's a graphing one. So I'm going to put in the 10. So 10 minus 5 divided by the, oops, I got to do that differently. 10 minus 5 divided by the 3 times 10 squared plus 2 times 10 plus 2 is going to give me 188, oops, 0.666. That seems like I don't agree. Hold on. So insert a parenthesis here. Oops, I don't know if that. Yeah. I was like, I forgot a parenthesis somewhere. I did. Okay, so this is 0.015. I was like, that's not going to 0. All right, so then I'm going to hit secondhand enter on the graphing calculator, and it's going to bring up that exact problem. And then I'm going to change my tens by inserting another 0 and making them 100. So there's an insert button as well right above the delete right here. So you can insert something into that function. So I'm changing all of my tens by inserting another 0, and then the number becomes 0.003. So it's getting smaller as the numbers get bigger, and that leads us to the 0. But I want you to look at this one and be like, okay, higher exponent on the bottom goes to 0. Higher exponent on the top goes to infinity. Same goes to the fraction. Okay. And our last one. Okay, so we look at this. This is our highest degree here, even though it's not written first. So x on the bottom and a third on the top. So top is getting bigger faster. Where are we going? We're going to infinity. So we know this is going to infinity. Now, we don't know if it's positive or negative. So we have to think that through. So we just put in these values of -10, and that will tell us. So get out my calculator again for this first one. All right, so I'm going to have -10 to the third plus 2 times -10 minus 1. I'm just going to hit enter and then divide that by 3 minus 8 times -10. and I get negative 12 on this one, 0.3. And if I did it again, well, I'll have to retype it in because I can't just change the numbers because the way I did it, darn me. Okay, so then plus 2 times 100. Oops, it's a negative 100. Negative 100. Oops, where was I? Minus 1. Okay, and then divide that by 3 minus 8 times negative 100. So I get negative 1245.58. So it's getting bigger and bigger in the negative, right? So we can assume this is negative infinity. Okay, so these ones are a little harder because you know they're going to infinity, but you have to decide if it's negative or positive. And again, you can always put in a value. Okay, the rest of this is just got some examples of asymptotes again, which we did in our review. So I think you're probably good with those. Vertical, horizontal, they're very similar. So I'm going to stop there because we've done that on our review the last week. So, all right, hopefully this was helpful, and let me know if you need help. And there are more videos from the company if you need like more examples as well.